So if we look at this bell work for today, what we have are different approaches for it. I got almost everyone to respond to this. And if I share the results just real quick, you can see where the results fall, and C was the most popular answer. So we're going to go through and figure out how to get those results, or the correct answer to this. So we want to, there's two different ways we can do this. If we understand what they're asking for, they give us 5 different answer choices right here. And so we can just plug numbers in until we find one that works. And that's not a bad strategy if that's the best thing you can think of and you've got limited time. So it's not a bad idea. We can do it slightly faster if we think through it ahead of time. So it says for 2 consecutive integers, that means any number and then the number that comes immediately after it. So 7 and 8 are consecutive integers. Now that makes sense because no matter where we look down here, we're going to see consecutive integers as answer choices. And this part of the sentence right here is actually an algebraic equation in disguise. So we can actually convert this into an algebraic equation. It says the result of adding the smaller integer and triple the larger integer is 79. So the is means equal. So equals 79. Now this and right here is the same as plus. So the result of adding the smaller integer, I don't know what that smaller integer is. I'm going to call it x, plus the larger integer. We know that the next integer is going to be that same value plus 1. So the larger integer is this right here. But we're not done because it says triple the larger integer. So actually one last thing I need to put in here is I'm going to multiply that larger integer by 3. So by doing this, I can actually solve algebraically for what the smaller integer is. So anyways, let's just run through this. So it's going to be x plus, when I do distributive properties, 3x plus 3 equals 79. I can combine like terms to get 4x plus 3 equals 79. And now I can subtract the 3. I get 4x equals 76. Divide by 4, x equals 19. So that's the smaller number, which means the bigger one has to be 20. And there it is. We can get it there. Now, of course, we'd want to confirm that. So if I took 19 and plugged it back in, it'd be 19 plus 3 times 20 equals, well, 3 times 20 is 60. So 19 plus 60 equals 79. There it is. We just confirmed it. So, if you can figure out that there's a way of modeling this with an equation, then that can make it go a little bit faster. So what we're going to be doing today is using trig for practical purposes, because again, it's important to do what we did on Thursday and Friday, but it's not sufficient because we still need to have the, do more with it. Sorry, I'm not speaking very clearly right now, but there are ways that we use trigonometry in order to solve for missing values, and that's going to be the important thing right here. So if we look at this problem, this is unlike the previous problems we were looking at, where the previous ones might have looked like this, where it says, okay, here's angles A, B, and C. Here are your side lengths. That's 5, that's 12, that's 13. And what is the sine of A, right? And that's what we've done. So at this point, hopefully everyone can tell me what the sine of A is. And what we're going to be doing today is a little different, is now we don't know the side lengths. In fact, if you look at this diagram, I only know one side length, but I do know that one of the angles is 18 degrees, and we haven't bothered with angle measures yet, and now we will. So with angle measures, here's basically how we approach this. We're going to be solving for a missing side length. Before we worry about setting any equation up or doing any calculation on this, the first thing I want to do is identify my reference angle. So my reference angle is the angle that they give me, not the 90, which is sitting right here. Oops. So I don't worry about the 90, but the reference angle is this 18, and hopefully we're all good with that. Then I want to label my sides hypotenuse, opposite, adjacent, and the hypotenuse is where I always start. It's the easiest one to identify. So I'll put an H right there for hypotenuse. Now, I will say this, the letter H can sometimes be used in other problems for height. So if there ever is a situation where you've got two different variables, both called H, and you're trying to say H is for hypotenuse, H is for height, then of course, in that situation, you might want to just write out HYP. So, that's a hypotenuse, the other H is height. Anyways, in this situation, that's not happening, so we're good. All right, the opposite side, my reference angle. Remember, this is like your left and your right. Left and right depends on where you're standing, which direction it is, right? Opposite and adjacent depends on which reference angle we're talking about. So in this case, my opposite is over here and my adjacent is right there. Okay, so the next question I want to ask in a problem like this is, what do I know and what am I solving for? What I know is that the adjacent side is 100 meters. What I'm solving for is the hypotenuse, which is unknown. I don't care about the opposite side. I do not care. So when I'm looking at SOHCAHTOA, and this is where you also might want to have your reference sheet available. If you're at home and you created one, it's a good idea to have that out. If you're here, it's a good idea to have this out for your reference. So sine, I'm just going to underline the first letter. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So knowing that I'm dealing with the adjacent and hypotenuse, which trig ratio would I want to use for this problem? Sine, cosine, or tangent? Any thoughts on that? Go ahead. Yeah, cosine. Oh, yeah. Yeah. Okay, so this would be, just like said, mentioned a second ago, this would be cosine, and let's figure out why it's cosine. Generically speaking, cosine of x equals the adjacent side over the hypotenuse. I want to know the hypotenuse, so I really want to make sure that's in my equation. I already know the adjacent, so it's important that I have my known information in there as well. There's nothing labeled on the opposite side here. So in this case, I don't care about the opposite, so I can just ignore tangent and sine, which both have opposite in them. So whatever way you like to approach this, if you want to think about it as like, what do I not need? And I can ignore those ratios. Or what do I need? And I can find the one that works. So if you notice in sine, that requires opposite. Tangent requires opposite. And I don't care about the opposite side. So however you like to approach this. Now what we can do is we can substitute in the values that we have. Cosine of 18 equals the adjacent side 100 over x, which is what we're solving for. That's my hypotenuse. Now this is an equation. We can solve it. Remember that cosine of a number, sine of a number, tangent of a number is just a number. If it's sine or cosine, it's going to be a decimal between 0 and 1. If it is if it's tangent, it's going to be any number between 0 and infinity, but a lot of times it'll still be a decimal. So anyways, at this point, this is a number, and that's maybe one of the key things to remember because it looks very different. It'd be one thing if I put what that number is. In fact, let's find out what cosine of 18 is. So I'm just going to type cosine 18. And I got 0.951. All right, you will want a calculator for this as well. There's no way of doing trigonometry without a calculator. So if you don't have one, I've got a number up here. You can, in the classroom, you can feel free to come up and grab one. At home, make sure you have access to some kind of a calculator. Okay, so this is 0.951. I could rewrite it this way, equals 100 over x. And there's nothing wrong with that, but typically we don't bother converting it into a decimal. We'll just keep it written as cosine of 18. I just want to emphasize it's just a number, okay? It's just a number. So let me erase all this. And let me also, this might or might not help you, but I want to show you that right now it's a little bit weird the way it's written, but maybe we can make this make a little bit more sense. I'm going to rewrite this as a proportion. Cosine of 18 over 1 equals 100 over x. What I'm saying is that this, because I have a right triangle with an 18-degree reference angle, I am going to have proportional sides. And so the fact that this adjacent side is 100 is going to tell me what the hypotenuse has to equal, because for every 18-degree angle, the cosine is a specific ratio. And that's stuff that's been figured out through the years. So we could almost do this like cross products at this point. So I could do 100 times 1 equals x times cosine of 18. All right, so x times cosine of 18 equals 100. And now I can just solve for x by dividing by cosine of 18. So that cancels out. And look, I'm moving it around just like I would any other number. So when I plug that into my calculator now, and this is where you can actually just straight up do this math with the calculator, 100 divided by cosine of 18. And if you can see on my calculator here, that last calculation I did where the cursor is blinking, it just is straight up 100 divided by cosine of 18. And I will get an answer. That answer is x equals 105.15 if I round it to the hundredths place. So we're using this rule about similar triangles, similar right triangles having the same ratios. We're using this fact to our advantage so that we can come up with missing side lengths. So if this is meters, I'd have my answer. Okay. Now, another thing we can do, and this is kind of a way of checking our work without formally checking it. I was solving for the hypotenuse. And what do we know about the hypotenuse as far as the length of it goes? It's the longest side. In every right triangle, the hypotenuse is the longest side. So if I'm looking here, notice that 105.15 meters, that's longer than the side that I started with. So that seems to make sense. This should be longer, and it is. So just on that front, we're good to go. Okay. So let me show you, we're not going to be doing word problems today. We're going to do one word problem. And what I wanted to do with this was just give you a heads up of how we can practically use trigonometry. So you are standing 100 feet back from a building and measure the angle from where you're standing up to the top. You get a measure of 75 degrees. How tall is the building? These are two things that are easy to measure. All right. So first of all, if this is the triangle and it represents this model, where would that 100 feet go? On the bottom, the right, or the hypotenuse? The bottom. We're talking about 100 feet back. So this is like we paced out 100 feet. And this is the building. Okay. So I don't have to draw an actual diagram, a model, but as long as we understand what this represents. I measure up to the top and I get 75 degrees. So which angle is 75 degrees? Is it the bottom left or the top? Which one? Okay, I see bottom left. Thanks, Dalen. And that would be. So, and this is something, again, we're not really going to be doing word problems today. We're going to build up to that. You will. But with word problems, when it's talking about the measure, we sometimes call this the angle of elevation. But basically, we're measuring from here. This would be 0 degrees. And then I'm going to be measuring up from there. And that's 75 degrees. All right. So it just, and this is something just to introduce you with the kind of language you're going to come across. So anyways, let me mark this. There's our 75 degrees. And what are we solving for? The hypotenuse or the right side? Which one represents the height of the building? The right side or the hypotenuse? The right side does. So I'll go ahead and put an H here for height. I could put an X just to say it's my unknown. So keep in mind, I drew this little model of a building here a second ago. You know, if there's a door and your windows or whatever, I don't know. I'm not going to go put detail into it. But if that's the building, then the height is that side right there. Okay, and this is where it's going to be important to kind of visualize what's going on. And this is where you could make mistakes, because every one of these you're going to model with a right triangle. You'll always start with that. But where your different values go for the specific problem, you know, that might be different. Okay, so is this making sense so far? Okay. So at this point, let me go ahead and erase the building part of it. This is what I have set up. And now if we label our sides, which one, I'll label the hypotenuse, but now which one's opposite and which one's adjacent? So which one's opposite? Is it the H or the 100 feet? H is opposite. Remember, 75 is my reference angle, which means this is my adjacent side. And here I might write hypotenuse just to clarify a little bit. So at this point, if I know the opposite, sorry, if I know the adjacent side and I'm solving for the opposite side, then what is my trig ratio? So let's remember, I don't care about the hypotenuse here. So which one am I going to use? Tangent. Notice tangent doesn't require the use of the hypotenuse. Cosine and sine both do. So in this case, it's going to be tangent of this random angle equals the opposite over the adjacent. And you can see now that you have to pick the right trig ratio so that you can set up your equation correctly. All right, so anyways, let's just finish it from here. Tangent of what angle? What's my angle here?
H over 100.
Okay, that would be you're right on the, that would be my ratio on the other side. H over 100, I can go ahead and fill that in, and I'll need to, because my opposite side is H and the adjacent side is 100. And Angelica got this right. The angle is 75 degrees. Remember, it's always the tangent, sine, or cosine of an angle. So there it is. Tangent of 75 degrees equals the opposite, which is our or the height, sorry. The opposite is the height over 100, which is the adjacent side. Now, this is pretty straight. If you want to think of it as a rate, as a proportion, you can. And what we're saying is that whatever the tangent of 75 is, the ratio between that number and 1 is going to be the same as the ratio from H and 100. All right, but let's not worry about the ratio or the proportion anymore. And let's kind of set it up the way that we would typically solve this. So I want to get rid of the denominator every single time. we're going to have a denominator and we don't want it to be there. So I want to multiply by whatever's in the bottom. If the h was in the bottom, I'd multiply by h, but now I'm multiplying by 100. So that causes those 100s to cancel out. I have 100 times the tangent of 75 equals h. And tangent of 75 is just a number. I can plug this into my calculator. So plug that into your calculator. I'm going to put an equal right there, and someone can write out what answer they find. So there we go. We do have the answer, and I'm just going to add the feet there. Now you'll see on Delta Math, it already has the units provided for you. But of course, we want to make sure we're including units if they have those available for us. So there we are. The building is 373.2 feet tall. And we got a very precise number, but now I hope this shows a little bit of the usefulness of trigonometry, because it's easy to measure 100 feet on the ground. It's easy to measure your angle looking up. We have tools for that. It's not easy to measure the side of a building that rises almost 400 feet in the air. Now, we could, and let's say it's a building, right? We probably don't need to know the height of the building necessarily. But let's say you're out and you're trying to figure out how high certain walls are on a canyon, how high some canyon walls are. And, you know, there are all kinds of practical things you can solve for here. If you know your horizontal distance from where you are to somewhere else, and you can measure an angle up to it, you can measure how high in elevation you have to go to get up to it. So we could go right now and we could measure the height to the top of Agassiz up on the mountains. And or we could measure if we knew our horizontal distance and we could measure our angle looking up to the top, then we could calculate exactly how tall that mountain is. So that's why you don't have to get up to the top and use really highly calibrated instruments. You can just use trigonometry and measure distances from a long ways away and measure heights. So just for this one example, I hope you're at least able to see there's a lot of usefulness with this kind of math. So your homework is going to be looking at Delta Math, and I'm going to go over there and we're going to do at least one more problem, maybe two more. So let me figure this out. Okay, I'm going to pick a different problem. So notice that all of these problems, the very first part of it, it shows the triangle setup right here. And then it asks you to find the length of ST. Okay, sorry, I have to re-sign in. Okay, so since Delta Math isn't working, the same basic types of problems are right here. And these are already set, but what you're going to find is you'll get a random triangle with certain measurements already given, and you're going to solve for one of the missing sides. So let's just look at problem number 2 to begin with. And we've already done this, so it's not going to be completely new for you. So the very first thing you want to do when you look at a problem like this is determine what's your reference angle. And in this case, 73 degrees right here is your reference angle. You are going to then label your sides. So you want to start with the hypotenuse, which is opposite your right angle, then the opposite, then the adjacent. And then the next thing you want to do, if you want to use that reference sheet, or if you've already got SOHCAHTOA and just this whole concept in your head pretty well, then you can figure out from this which trig ratio is appropriate to use. Does anyone know and can quickly tell me which trig ratio is appropriate for this? All right, I'm hearing cosine. Notice that I'm solving for the adjacent side. I know the hypotenuse. There's nothing given on the opposite side, so I'm just going to ignore it. So there it is. It is cosine. Cosine of my angle equals adjacent over the hypotenuse. And from here, I'm going to plug numbers in. So it's going to be cosine of 73 degrees equals I noticed I didn't write degrees, but it's just understood it's degrees. Maybe it's better to show that. There it is. So at this point, adjacent over hypotenuse. What's my adjacent side in this problem? X is my unknown. What's my hypotenuse? 6. There it is. So now we just want to get rid of the denominator, which is 6. And when that cancels out, I've got my answer. 6 times the cosine of 73. And I can multiply that out using the calculator. All right, again, someone can write in the answer on the screen when they get it. So there we go, 1.75. And sometimes it'll tell you specifically what to round it to. Rounding it to the hundredths is always a good place to do it. Actually, if we zoom out a little bit, it says round to the nearest tenth. So we can actually round this off from here because it's 1.754. What would this round to the nearest tenth? 1.8 feet. Make sure you're getting that rounding correct. All right, and do pay attention. If it gives you instructions on what to round it to, go ahead, pay attention, and make sure you're following those instructions. Okay, so 1.8 feet. So this makes sense visually, because look, this side, and I know we're calling it feet. It doesn't actually give us a unit. We can pretend it's feet. If it doesn't give you a unit, you don't really need to write one. So this side right here is significantly smaller than 6. It's not always going to be drawn to scale and drawn accurately, but we do know that the hypotenuse should be the longest side. So we've definitely got that part correct. Okay, so what I want to do with the next problem, and I'm going to pick real quick which problem I want to do this with. I want you guys to, at home, do the math yourself. Okay, let's go with problem number 6. I want you guys to copy this down. I'm going to give you a couple of minutes to work on this and to see if you can come up with the correct answer. And then we're going to run through the full process in just a minute. All right, here's what we're going to do. We're going to start the process. I want someone to write on the triangle, mark where the reference angle is, and label the sides as hypotenuse, opposite, or adjacent. And let's just start with that. Now that we see where the hypotenuse, opposite, and adjacent are, and just in your head, you can think, what side do I know? What side am I solving for? And as you're answering that question, if someone can come up with the correct trig ratio to use, write it on the screen. Which trig ratio is appropriate for this problem? Awesome job right there. So not only did we figure out it's got to be sine because we know the opposite and we're solving for the hypotenuse. So sine, if we were to think of SOHCAHTOA, sine is the opposite over the hypotenuse. That's what that so means in SOHCAHTOA. So not only that, but Daylum and filled in the rest of the equation with the opposite being over the hypotenuse. Now we can just go through and solve. I'll just do the algebra real quick. Actually, real quick, if someone already came up with an answer, I'm going to pause the video. Someone write the answer down that they already came up with. So if this is done correctly, it looks like it should be 18. Now, just without having done any of the math yet, we can see that what we're solving for is a hypotenuse. It should be the longest side. So 18 being the answer makes sense because the opposite side is 14. The hypotenuse should be longer than that. All right, so let's figure out what we're doing. We want to get rid of that denominator, so I'm going to multiply both sides by x. And what I get when those cancel out is x times the sine of 51 equals 14. Now I want to get x by itself. I'm going to divide by the sine of 51. Oops, not by 14. Sorry about that. That should be divided by the sine of 51. And now if you plug in that into your calculator, let's see if you also get 18. Okay, so there we go. 18 is the answer, and it all checks out. I'm going to clear this. All right. And let's see. What else is I going to do here? So anyways, I don't know if we need to see another. I feel like we do because there are a lot of people who just weren't getting much progress made on the previous problem. So I'm going to look at this one right here, number 10, because this one looks a little different. All right. So look at that one for a minute, and I'll just run through the process in a little bit. All right. All right. So I'm just going to run through this. I'm not going to have you guys bother writing on the screen. And I just want, hopefully this is just a check of your own work to see that you did it correctly. So my reference angle is 68. I'm going to label my sides. There's my right angle, which means there's the hypotenuse. So the hypotenuse is right here. My unknown is the opposite side. The 21 is the adjacent side. And because I'm not using the hypotenuse at all, the only trig ratio that uses opposite and adjacent is tangent. So that's what I decided on. It's going to be the opposite over the adjacent. The tangent of my reference angle is 68 right here equals the opposite, which is unknown, over the adjacent, which is 21. Okay, so now I can multiply both sides by whatever's in the denominator, which is 21. So when I multiply both sides by 21, I get 21 times the tangent of 68 equals x. And now I can just plug that into my calculator and I can tell you what x equals. I haven't done this yet, so let's see. It's 21 times the tangent of 68. And I got 51.9768, dot, dot, dot. If I wanted to round this to the nearest tenth, this 7 rounds this up, which means that becomes 52.0. Make sure you round that correctly. All right, so this is just confirmation. If you ran through the full process, if you got 52, then you're probably pretty good to go. The last thing I wanted to say, and I'm not going to base this on a particular problem. So if I zoom in, I just want to get to a blank screen. So here we go. It's a blank screen. Let's imagine that I have the cosine of 35 equals 7 over x. When x is in your denominator, I want to kind of show you what happens. This is a shortcut you can choose to use if you find it helpful. All right, so I multiply by x on both sides. And then I get x times the cosine of 35 equals 7, because these x's canceled out. And then I divide by cosine of 35. So this is a little bit of work, right? And you get x equals 7 divided by the cosine of 35. Now, look at where we started. We started with this. The cosine of 35 equals 7 over x. So the shortcut here, if this is something you find helpful, when x is in the denominator, and this is where you have to be careful, when x is in the denominator, you can just take these two values and flip them. And notice, if I flip those values, I get this equation right here. Does that make sense? Okay, so again, you have to be careful with that. If x is in the numerator, then you don't need to bother with a trick. You just multiply by the denominator on both sides. Okay, so if that is not helpful, if that confuses you more than it helps you, then just ignore it and solve it algebraically like you always would. But anyways, that's what you're going to do. If Delta Math is not working, then what I intend to do is put up this PDF so that you guys can work on that, and we'll do this as your homework instead of Delta Math. So that might be the better option at this point. So with that, if you still have questions, if you want to look through some more of these to get some help, please stick around. Otherwise, you can feel free to try out Delta Math to see if it works. And if it's still not working, just hang on for a little bit and I'll get this PDF uploaded. And yeah, that's about it. So have a good day and I'll see you tomorrow. Stick around with any questions.